This is a solution for a question covering the sublearning outcome of hydrostatic and soil loads from Mechanics 1. This question asks us to find the total moment about Q produced by the forces that act on the retaining wall, which is shown below, assuming that the wall is 1 meter long. We also note that the forces consist of two components, a UDL on the horizontal leg and a triangular load on its vertical leg. These soil pressures depend on the density of the soil and on K, which is the coefficient of lateral soil pressure. Both diagrams shown here underneath display both the horizontal load as well as the vertical load. We would also like to know if the wall will overturn, and this question has therefore reduced the pressure distributions into point loads. Firstly, we will find the horizontal and vertical point loads. Starting with our horizontal load, we can find the total force acting horizontally by recalling that force is equals to pressure times area. The pressure acting horizontally is represented here, and it is 10 kPa. Area of this UDL can be found by considering that this load is showcased as a triangular distribution, which means the area of a triangle can be used. As a result, we have half times base times height times the pressure at the base, which is equals to half times 1 meter times 2.1 meters times 10 kPa, which is equal to 10.5 kilonewtons, and this is equivalent to the horizontal point load. The vertical point load can now be found. Similar to the horizontal point load, force can be found using this formula. However, now the vertical load acts as a rectangular distribution, while previously a triangular distribution was used. Pressure, as shown here, is 45 kPa, while the area is found as length times width. The question mentions here that the wall is 1 meter long, so this is the length, while width is also 1 meter, as we previously recall. As a result, we calculate that 45 kPa times 1 meter is equivalent to 45 kilonewtons, and this is the vertical point load. We can put our solutions from the first question to the side and move on to the second question, which asks us to find the moment generated by the horizontal pressure around Q. The moment around Q for the horizontal pressure can be found by multiplying the force on the horizontal surface by the distance from the point. Previously, the force on the horizontal load was found to be 10.5 kilonewtons. We must also note that since this is a triangular distribution, its centroid is located here in the diagram, which is 1/3 of the total length. As the length was 2.1 meters, our distance is equals to 0.3 times 2.1, which is 0.7 meters. As a result, total moment is equals to 10.5 kilonewtons multiplied by 0.7 meters, which is equivalent to 7.35 kilonewton meters. Also of key significance here is that the moment is acting counterclockwise as it causes the wall to turn this way. As a result, the final solution is 7.35 kilonewton meters in the counterclockwise direction. The following question asks us, what is the moment generated by the vertical pressure around point Q? Using the same formula, we now have to consider the vertical load only, which was found here as 45 kilonewtons. Since this is a rectangular distribution, the centroid of this force acts at half the total distance from Q. The total distance is 1 meter, so d is equals to 0.5 meters. Performing the moment calculation, the final answer is 22.5 kilonewton meters. As shown here, it causes the wall to turn in a clockwise direction, so the final answer is 22.5 kilonewton meters clockwise. The final question asks if the wall has any potential to overturn. To determine this, we would have to consider the balance of moments. If the counterclockwise moment due to horizontal pressure exceeds the clockwise moment due to vertical pressure, the wall could potentially overturn. We would then have to perform a summation of moments. Firstly, let us assume that the positive notation is in the counterclockwise direction. From our previous calculations, we had the horizontal moment to be 7.35 kilonewton meters in the counterclockwise direction. Therefore, this is equals to positive 7.35 kilonewton meters. On the other hand, the vertical moment was 22.5 kilonewton meters in the clockwise direction. So this is negative 22.5 kilonewton meters. Therefore, positive 7.35 kilonewton meters minus 22.5 kilonewton meters is equal to negative 15.15 kilonewton meters. As the final solution is negative, this indicates that the clockwise moment is much larger than the counterclockwise moment. Therefore, the wall will most likely not overturn. So the answer is no.